Hello, in Chapter 4 we're going to be looking at statically equivalent systems. So all of this starts with forces. So we've already talked about point forces. This is where the force is represented by a single vector and it's going to have a single point of application. But in this chapter we're also going to be discussing something called distributed forces. This is where a force does not have a single point of application. Instead, it's spread out over some sort of surface. With this is a lead-in to the idea of statically equivalent systems. So statically equivalent systems are going to be systems of forces or moments that cause the same end result. They cause the same acceleration in an unrestrained system, or they cause the same reaction forces in a constrained system. So with point forces, we're often going to talk about the resolution of a force into a force in a couple, which is going to allow us to kind of move forces around. And we do all of that usually to come up with what's known as the equivalent force couple system. This is where we have some initial complex set of forces and moments, and no matter how complex the system is, we can always reduce the system down to a single force and a single moment, or couple, pure moment, that is statically equivalent to the original set of forces. All of this, the process-wise, is similar to equilibrium analysis for rigid body systems, so we're going to use much the same method that we used for that. In the other line, we're going to look at distributed forces and how do we turn that into what's known as the equivalent point load. So distributed force is more difficult to work with in analysis, and so often we're going to try to create a single point force that is statically equivalent. It's going to cause the same accelerations or the same reaction forces as our original distributed force. So with the equivalent point load, we've got two different methods that we can use to find that. So first we've got moment integrals, and we're going to discuss that here in the chapter. And there's also a second method that uses centroids. So centroids are discussed in Appendix 2, but it forms the basis of a second method for finding the equivalent point load for a distributed force. All right, that's all we have in this chapter. Thank you for watching, and I hope to see you again.